Hello, I'm Ofir Reich, and I'll be presenting Is Model Accuracy Enough? A field evaluation of a machine learning model to catch bogus firms. This is joint work with Taha, Barwahwala, Aprajit, Mahajan, and Shekhar Mittal. And what we do in this paper is we try to find bogus firms. These are fraudulent, non-existent firms that only exist on paper and facilitate tax evasion, specifically evasion of goods and services tax or value-added tax. These are generally found through physical inspections, where the tax department sends inspectors to the registered address of the firm, finds that there's nothing there, concludes that the firm is non-existent, and then cancels them and revokes their license. In this research, we partner with an Indian state and use a very rich data set of the universe of tax returns plus inspection results. And we train a machine learning model to detect the bogus firms. And then we go one step further and test it in the field. What do we find? First, we find that model predictions are indeed accurate. They're accurate on the test set. They're also accurate in field inspections. What we did is we shared 4 lists of firms, which are the top model recommended firms with the highest scores, to be inspected by the department and record the results of the inspections, and found that in those inspections, the model recommended firms are much more likely to be bogus, about 50%, than a random set of firms with about 4%. And then the model predictions are also accurate in cancellation. So if we compare our firms shared into different lists with all other firms, baseline firms, and the trend of cancellations over time, we see that our model recommended firms are canceled at a much higher rate. However, we held out 10% of the recommended firms as a control group, where we did not share them with the department, we did not perform inspections on them, and we then track their cancellations over time, along with the list firms. And we see that actually the trend in cancellations is very similar, if anything slightly higher in the non-shared group, but this is probably noise. So there's no causal effect of sharing the list firms with the department on cancellations. How could we reconcile those two facts, the model accuracy with the lack of treatment effect? So first, the model seems to have predicted firms already on a trajectory to be canceled, even if they're not sent on new inspections by us, maybe by overfitting to proxy-labels, and there's more details on this in the paper. The second reason could be lacking department action. So maybe even we see that even firms that were inspected and found to be bogus were not canceled even more than a year later. And we find that both of these are at play. So to sum up, our takeaway is that a field evaluation of models is critical. So you can't just rely on test set performance and say that the model is good enough. You have to really monitor the deployment in the field and do a controlled trial to see that it works. Thank you.